alternator is an electrical generator and convert mechanical energy to electrical energy in the form of alternating current. For reason of cost and simplicity, most alternators use a rotating magnetic field with secondary armature. Alternatively, a line alternator or a rotating armature with secondary magnetic field is used. In principle, any AC electrical generator can be called an alternator, but usually the term refers to small rotating machine driven by automotive and other internal combustion engine. An alternator that uses a permanent magnet of a magnetic field is called a magneto. These machines are largest energy converters found in the world.
Go till I finally prove it. Never listen to the no's, I just wanna keep moving. Yeah, I put
An alternator has three-phase winding on the stator and field winding on the rotor. Stator. It is stationary part of the machine and is built up of silicon steel lamination having slot on its inner periphery. A three-phase winding is placed in the disc slot and serves as the armature winding of the alternator. The armature winding is always connected in star and the neutral is connected to ground. Okay, next, rotor. The rotor carries a field winding which is supplied with a direct current through two slip rings by separate DC source. DC source, called exciter, is generally a small DC shunt or compound generator mounted on the shaft of the alternator. Rotor construction is of two types, namely first silent or projecting pole type and second non-silent or cylindrical pole type. Okay, now I will explain about silent pole type. In this type, silent or projecting pole are mounted on a large circular steel frame which is fixed to the shaft or the alternator as shown in diagram. The individual field pole winding are connected in series in such as a way that when the field winding is energized by the DC exciter, adjacent pole have opposite polarities. Okay, for my last part is non-silent pole type. In this type, the rotor is made of smooth solid forged steel radial cylinder having a number of slots along the outer periphery. The field windings are embedded in this slot and are connected in series to the slip ring through which they are energized by the DC exciter. The region forming the pole are usually left unslot. It is clear that the pole formed are non-silent. They not project out from the rotor surface.
Okay, my name is Azfar bin Fauzi and I will explain about principle of component. From all of the component, the main component in that playing the most important role in an alternator consists of stator and rotor. But unlike the other machine, in the most of the alternators, field exciters are rotating and the armature coil are stationary. Why armature coil are stationary in an alternator? First, at high voltage, it is easier to insulate the stationary armature winding, which may be as high as 30 kV or more. Second, the high voltage output can be directly taken out from the stationary armature, whereas for a rotary armature, there will be large brush contact drop at higher voltage. Also, the sparking at the brush surface will occur. Third, field exciter winding is placed in rotor and the low DC voltage can be transferred safely. Fourth, the armature winding can be braced well so as to prevent deformation caused by the high centrifugal force. Is a figure of how alternator or AC generator works. According to the Faraday law of electromagnetic inductions, whenever a conductor moves in a magnetic field, EMF gets induced across the conductor. If the closed path is provided to a conductor, induced EMF causes a current to flow in the circuits. Based on the picture, the conductor coil ABCD is placed in a magnetic field. The direction of a magnetic flux will be from an N pole to an S pole. The coil is connected to slip rings, and the load is connected through bushes resting on the slip rings. Consider the coil is rotating clockwise. In this case, and the direction of induced current can be given by a Fleming right-hand rule, and it will be along ABCD. As the coil is rotating clockwise, after a half of time period, the position of the coil will be as in the second case of above figure. In this case, the direction of the induced current according to Fleming right-hand rule will be along DCBA. It shows that the direction of the currents change after half of the time period. That means we get an alternating current.
Able, oh yeah, I'm stable, oh yeah, no label, oh yeah, you know me.
This is circuit diagram for alternator. Okay. This is a main part. That is a rotor and stator. Okay. The rotor is carries a field winding which is supplied with a direct current through two slip rings by a separate DC source. This DC source, or known as exciter, is generally a small DC shunt or compound generator mount on the shaft of the alternator. Okay, and the next one is stator. You know, the stator is stationary part of the machine and is built up of sheet steel lamination having slots on its inner periphery. Okay, this is a three-phase winding is placed in that slot and serve as the armature winding of the alternator. The DC current from the regulator is through the rotor and transform it to the AC current to the output diodes. It has 6 output diodes, 2 per phase to make a full wave rectifier. Okay, the positive output diode will connect to the positive battery and the negative output diodes will connect to the ground and the negative of diode trio, and the positive of diode trio will connect to the field current supply to the regulator, and it will also connect to the positive battery, and the positive battery will control voltage input to the regulator, and the negative of the battery will connect to the ground.
If you want it bad, I'm gonna show you where it's at. Yeah, how you can get it back. Yeah, cause I ain't never.
Okay, for my slide, I will discuss about the title related equation. First, the alternator equation. The direction of induced EMF can be found by Fleming's right-hand rule, and frequency is given by F equals to NP over 120. N is speed of vector in RPM. P equals to number of poles. Okay, the distribution pitch. A winding with only one slot per pole per phase is called a concentrated winding. KD equals to EMF with distributed winding over EMF with concentrated winding. Next, pitch factor. A coil whose sides are separated by one pole pitch, i.e. coil span is 180 degree electrical, is called a full pitch coil. P equals to EMF induced in short pitch coil over EMF induced in full pitch coil. We have to note full pitch winding Kp, which is distribution factor, equals to 1, while short pitch winding pitch factor Kd lesser than 1. EMF equation of alternator. Let Z equals to number of conductors or coil in series per phase. Flux equals to flux per pole in Webers. P equals to number of rotor poles. N equals to rotor speed in RPM. Kf is form factor equals to 1.11. D flux equals to P flux, while dt equals to 60 over N. We can conclude that average EMF induced in one stator conductor equals to D flux over dt equals to P flux per 60 over N. Lastly, P flux N over 60. Okay, this is the step by step to create alternator formula. Average EMF per phase, which is the slide before. You can see P flux N over 60 times Z. Okay, P flux Z per 60, and we come out the N. times equals to 120 F per P equals to 2F plus Z volts. RMS value of EMS per phase equals to average value per phase times form factor. As we know, form factor before equals to 1.11 equals to 2F plus Z times 1.11. Lastly, the equation will be 2.22 F plus Z volts. The ERMS per phase equals to 2.22 F plus Z units of volts. Okay, if Kp and Kd are the pitch factor and distribution factor of the armature winding, then ERMS per phase equals to 2.22 Kp Kd S plus Z volts. Sometimes the turns T per phase rather than conductors per phase are specified. In that case, equation 2 becomes ERMS per phase equals to 4.44 Kp Kd F flux T in units of volts. Note, the line voltage depends on star and daughter connection.
To love what I'm doing, never give up, never slow till I finally prove.
Alternator has many use for nowadays industrial application such as to combine heat and power. Industrial alternators are capable of working in a combined heat and power environment in order to achieve prime rating result. Grid code. Alternators can help to meet your electrical and mechanical performance need in any prime power application for grid code. Mobile construction. With a range of different power requirements, alternators have been designed to be flexible for your mobile construction requirement. And lastly, prime power. For standard base load power supply, alternator range offer low, medium and high voltage alternators up to multi-megawatt capabilities.
Always do it on my own, so I gotta get through it. And the only
Assalamualaikum. I have this down a few advantages and disadvantages in using alternator. First, I will explain the advantages and then the disadvantages of using alternator. The first advantage for using alternator is that there is no need for matching voltages. A DC generator must produce voltage at the level at which it will be used. AC has the advantage of allowing you to convert the current to a different voltage using a transformer. Transformer works with AC only and not with DC. The next advantage is travel over longer distances. This is because AC has the advantage of traveling over longer distances with less loss of power than DC. Transforming the current to a high voltage reduces the current, which in turn reduces power loss. This can be seen from the formula P equals to I square R, where P is the power loss due to resistance, R is the resistance and I is the current. Because I is squared to the power formula, decreasing the value of current or I by a little by increasing the voltage can decreases the power loss a lot. For the next advantage is that alternator is simpler in design than DC generator. The design of the AC generator is fairly simpler than DC generator. If required, DC output can be achieved from an AC generator by using a rectifier arrangement of diodes. On the other hand, getting AC from a DC generator either requires some modification in the generator's design or a complex circuit. AC generators don't require commutators and brushes since they can use a rotating magnet inside a fixed armature. This is not possible in DC generators. This reduces the wear and tear of the AC generator's part. Lastly, alternator is easy and efficient. There is not much to say about this because it is already explained in the previous advantage. AC is very easy and efficient to transmit over long distances rather than DC. Moving on to the disadvantages of alternator. The first disadvantage is that it is transformer requirement. AC generators have the disadvantage of requiring transformers, which complicates the circuitry. They must be designed so that the higher voltage on one side doesn't discharge. High voltages are not generated efficiently, so low voltages are generated, and the voltage has to be transformed to a higher level for long distance transmission. Next, a safety related disadvantage of AC is the increase in danger of electric shock due to the use of higher voltage for long distance transmission. This is why long distance transmission uses power lines kept high up the ground. Moreover, they can spark or overheat because of the high current. Lastly, alternator require more insulation because of the higher voltage.
Always do it on my own, so I gotta get through it. And the only thing I know is to love what I'm doing.
Okay, alternator is easy and efficient than DC motor because it is easier and efficient to transit over long distance rather than DC. After that, it is also simpler in design rather than DC because DC output can be achieved from an AC generator by using a rectifier arrangement of diodes. On the other hand, getting AC for a DC generator either requires some modification in the generator's design or a complex circuit, while AC generators don't require commutators and brushes since they can use a rotating magnet inside a fixed armature. Thus, this is not possible in DC generators. Then it is made that the AC generator is simpler in design than DC. Other than that, the AC generator also travel longer distance with low power loss than DC. AC has the advantage of traveling over long distance with less loss of power than DC, that transforming the current to a high voltage reduce the current, which in turn reduce power loss. This can be seen from the formula P equals to I square R, where P power loss due to resistance, R resistance, and I is current. And the AC generator also easy to convert to the current rather than DC because it does not need for matching voltage. A DC generator must produce voltage at the level which it will be used, while AC has the advantage of allowing you to convert the current to a different voltage using a transformer, and transformer works with AC only and does not DC. Finally, the alternator makes our life easier because it is easy and efficient, simpler in design, travel longer distance with low power loss, and easy to convert the current rather than DC.